Now next topic, that is motion of a vehicle on banked curved road. Now see here, we already discussed about the maximum safe speed for the level curved road, right? So if any vehicle move on that particular road with speed greater than V maximum, which is equal to under root mu S R G, definitely that vehicle will slip off. Now here on that particular road, if you want to increase the maximum safe speed, then what we have to do? We can't change the radius of the curvature. We can't change the coefficient of static friction between tire and surface of the road, right? So here in that particular equation we can't change anything. And then also if you want to increase the maximum safe speed, then what to do, right? So let's discuss this motion of a vehicle on banked curved road. Suppose the road is banked at angle theta towards the center. So angle is made at the center by this banked road, and that is equal to theta. Now let's derive the equation for the maximum safe speed in this particular case. Now here again think about the forces acting. Weight of the car mg vertically downward. Normal reaction perpendicular to the surface. If this angle is theta, here this will be also theta. So you will get components of this normal reaction, that is n cos theta vertically upward, n sin theta in horizontal direction, and that is towards the center. Then the friction between tire and road parallel to the surface, right? And that is towards the center, which will provide the required centripetal. So here also, if we take the components of this one, because here the road is inclined at an angle theta. So if this angle is theta, this will be also theta. So in this particular case, we will have the components of frictional force F cos theta towards the center and F sin theta, that is vertically downward, right? So here in this figure all the forces are represented from the common point. So we can say that is free body diagram. Now here in vertical direction there is no acceleration. So in other words, we can say there is vertical equilibrium. It implies that we can write n cos theta, that is equal to f sin theta plus mg. Okay, n cos theta, that is f sin theta plus mg. And the forces which are towards the center, here two forces are towards the center, n sin theta, f cos theta. So these two will provide the required centripetal force. So here in this equation, if we make mg as a subject of equation, we can write n cos theta minus f sin theta. Now the required centripetal force mv square by r will be provided by these two forces which are towards the center, f cos theta and n sin theta. Therefore mv square by r, that is n sin theta plus f cos theta. Now take ratio of equation 3 and equation 2. M will be cancelled, so we square upon Rg, that is n sin theta plus f cos theta upon n cos theta minus f sin theta. Now here if V increases, then definitely F also increases to provide the required centripetal force. But F can be increased up to certain limit. So for the maximum safe speed Vmax, here we can take F, that is equal to Fs maximum. So here we can write one more step, and that is V square maximum upon Rg, that is equal to n sin theta plus Fs maximum cos theta upon n cos theta minus Fs maximum sin theta. Now this Fs maximum, that we can replace by mu s into n. So we can write this is equal to n sin theta plus mu s into n cos theta upon n cos theta minus mu s into n sin theta. Now if we take n common, then that will be cancelled. Clear? Now if we take this Rg on right hand side, then we can write V maximum square, that is Rg into sin theta plus mu s cos theta, numerator, and denominator cos theta minus mu s sin theta. Now on right hand side, divide numerator and denominator both by cos theta. So here sin theta upon cos theta, that is tan theta, cos theta cancelled, so plus mu s, cos theta upon cos theta 1 minus mu s sin theta upon cos theta, that is tan theta. So mu maximum, that is under root Rg into mu s plus tan theta upon 1 minus mu s tan theta. Now remember, on level curved road, the maximum shape speed was under root Rg into mu s. But here see, something is added to mu s plus tan theta, and then after that numerator is divided by the term which one is less than 1. So definitely this bracketed term, that will be greater than mu s. So we can understand this thing. Now this maximum shape speed on the bend curved road, that is greater than the maximum shape speed on the level curved road. So to increase the maximum shape speed on the given level curved road, we have to give inclination to the road like this by some angle theta. Clear to all of you? Let us consider following two special cases in this discussion, right? Suppose in the equation of V maximum, previously we derived, if we take mu s, that is equal to 0, it implies that the friction does not act, or we can say the friction is minimized one, right? So if we take mu s equal to 0, our equation turns to V, that is equal to under root Rg tan theta. This is denoted as VO. This particular speed, that is known as optimum speed. If the vehicle is moved on that particular bend curved road with this speed, then the friction, that will be least one, and the contribution of friction in the centripetal, that will be almost 0, right? So in that particular case, the wear and tear of the tires of vehicle, that will be minimum 1. So if vehicle is moved on that particular bend curved road with this speed, which is known as optimum speed, then wear and tear of the tires can be minimized. Now let's think about another case. If speed is less than optimum speed, right, then what happens? The frictional force will act in opposite direction, means towards higher side. So vehicle will slip off inside, right? So on the bend road, if you want to park the vehicle, right? So in that particular case, your tan theta, that should be less than or equal to mu s. If this condition is not satisfied, and if you park the vehicle on the banked road, then it will slip off towards the center. Clear to all of you?